Hello everybody. Today we are going to discuss the basic theory of circular races. Well, let us say there is a circle with a circumference of 480 meters. X is the starting point from which A and B run in the same direction at speeds of 20 meters per second and 30 meters per second respectively. When and where will they meet for the first time? That is the question. As you can see in the figure, in 1 second A has run 20 meters and B has run 30 meters. This problem is just like clock problems, where we try to find out when the two hands, hour and minute hand of a clock meet each other. So we have to look at the difference in speed or relative speed here. Obviously, try to imagine two different colored dots, one black and one green, going round a circle in the same direction with different speeds, and try to imagine how they will move. If you think initially it may look like these 2 points or dots are never going to meet each other. Let's see whether it really happens or not. We'll solve this sum by 3 different methods so that at the end of the period the concept should be crystal clear to you. First method. A does one round in 480 meters by his speed of 20, that is 24 seconds. B does one round in 480 by 30, that is 16 seconds. Now, if we take the LCM of time taken by each of them, 16 and 24 seconds, we get the answer 48 seconds. In 48 seconds, A and B will both be at the same point again on the circumference. Let us check it. In 48 seconds, A does 2 rounds, that is 48 divided by time taken by A to do 1 round, that is 24 seconds. So A does 2 rounds in 48 seconds and B does 3 rounds in 48 seconds. So both of them are at the starting point after 48 seconds. The thing to note here is that A and B will meet for the first time at any point where the faster runner B would have done 1 round extra than the slower runner A. If you have seen Grand Prix races or F1 races, you will find that the faster cars overtake the slower cars by laps when they do exactly 1 more lap than any other slower car. Again, let's do method 1 again. A does 1 lap in 24 seconds, B does 1 lap in 16 seconds. So they will do a whole number of laps in 48 seconds. They will meet at the starting point when A has done 2 rounds and B has done 3 rounds. If we look at the clock problem perspective, in clock problem we look at what is the beating time or overtaking time. So B beats A by 10 meters per second. Now we understand, if we try to think a little in depth, that B will overtake A by exactly 1 round when they will meet for the first time. When will that happen? That will happen when B beats A by exactly 480 meters. How long will that take? That is going to take 48 seconds, because 480 divided by 10, 48 seconds. Again, like earlier, in 48 seconds, B runs 3 rounds. In 48 seconds, A runs 2 rounds. So they meet at the starting point. We can look at a third perspective. They will meet when A does X rounds and B, being the faster runner, does 1 extra round, that is X plus 1 rounds. Time taken is same. For 1 round, A takes 24 seconds. So for X rounds, A takes 24 seconds. For 1 round, B takes 16 seconds. So for X plus 1 rounds, B takes 16 into X plus 1 seconds. This total time for A and total time of B is same. Solve the equation, you get x equal to 2. What is x here? X is the number of rounds done by A. So when A does 2 rounds, B does 3 rounds, they again meet at the starting point. If you look at all the 3 methods, basic concept remains same, get the same answer. A does 2 rounds, B does 3 rounds. In 48 seconds, A does 2 rounds, B does 3 rounds. X is 2, x plus 1 is 3. Hope this would have clarified the concept somewhat. The obvious question that comes to our mind when we do this sum is, will they always meet at the starting point? Well, let's check out. Slight variation of the question. A and B run round a circular track starting together in the same direction where speed of A is greater than speed of B, and they meet after B has run 4.5 rounds. Find the ratio of their speeds. Repeat. A and B run around a circular track starting together in the same direction where speed of A is greater than speed of B, and meet after B has run 4.5 rounds. Find the ratio of their speeds. Now we can immediately understand from our previous example, speed of A by speed of B, same as rounds run by A divided by rounds run by B. B runs 4.5 rounds. In the same time, A being the faster runner here will run 1 round extra just when they meet. So the ratio of the speeds will be rounds run by A divided by rounds run by B. 5.5 by 4.5, 11:9. I hope this concept you will be able to use now in any kind of variations. Thank you.